Okay, we're going to solve a quadratic equation that happens to involve some trig functions. So 2 cosine squared of theta plus cosine of theta equals 0. Now getting started on this hopefully isn't too bad. We have 0 on one side. Let's think about factoring the other side. So in looking at those two terms, they both happen to have a cosine. Cosine of theta. So what I'm going to suggest is go ahead and factor out that common factor and think to yourself, all right, cosine of theta multiplied by 2 cosine of theta would give us that first term. And then we're going to need cosine of theta multiplied by 1 to give us that cosine of theta, that second term. Now that we've done a little bit of factoring, what I'm going to suggest is we go ahead and set each factor equal to 0. So we've got cosine of theta. We're going to set it equal to 0. And then we have 2 cosine of theta plus 1. We're going to set it equal to 0 as well. Now the cosine of theta equals 0, that's kind of solved down sort of already. The idea, isolate the cosine of theta on one side. On the right-hand side though, let's do a few steps and isolate the cosine of theta. First thing I'm going to do is go ahead and subtract 1 to the other side. And then to finish this up, the 2's connected there with multiplication out in front. Let's go ahead and divide both sides by 2. All right, not too bad. Next, let's think about cosine of theta equals 0. We'll do these separately. So cosine of theta equals 0. How I like to think about zeros and -1 and +1 whenever we have cosine or sine equaling those is I like to think about these as points on our unit circle. So our unit circle going on here is defined to be any point. It's going to be, first of all, cosine of that angle and then sine of that angle as ordered pairs. So if we know cosine of theta equals 0, what that's saying is our ordered pair is going to have 0 as its x value. And thinking about the unit circle, that means we don't move left or right, but we get a point on the unit circle. So I think that's happening here at the top or at the bottom. All right, so that top value is going to be pi over 2, and the bottom value is going to be 3 pi over 2. And the ordered pairs to go along with those are 0, +1, and 0, -1. But notice that each one of those x values is going to be 0. All right, so we've got a couple solutions. We know that theta can equal either that top one, pi over 2, or theta can equal 3 pi over 2, the bottom one. All right, remember our theta is an angle, so it's going to be the angle that goes along with that. To make this all solutions kind of case, what we always want to do is add at the end the original period for cosine multiplied by k, where k is some integer. All right, same thing is going to go on for this solution. 2 pi, the original period for cosine, because remember that was our equation, cosine of theta equals 0, multiplied by k, where k is an integer. So I'll write that k is an integer. All right, now how it works out is these two can actually kind of be combined together. If you wanted a little bit cleaner solution, that works out to be pi over 2 plus pi multiplied by k, because it keeps repeating itself every half time around the circle. You get an additional solution, and half the way around the circle is just pi instead of 2 pi. So if you wanted to combine them, you could make it a little bit cleaner with this as your final solution. Now we haven't dealt with cosine of theta equals -1/2 over on the right-hand side. So let's jump over there and deal with it. Now 1/2 is a nice value that shows up pretty regularly when we're thinking about these types of equations. Maybe a handy dandy chart you have, but we have -1/2. So what I want us to do is think about a reference angle. All right, the reference angle that corresponds with this, and I'm going to label that as theta bar, is the angle that would give you +1/2 if you plugged it into cosine. So that works out to be pi over 3. All right, the next thing I'd like to think about is using that reference angle in the appropriate quadrants to give us angles that when we plug them into cosine gives us -1/2. So when I do that, what I'm going to do is I'm going to think of this phrase, all students take calculus. All right, this phrase, mnemonic device, reminds us which quadrant each one of these trig functions is positive in. Now, all of them are positive in the first quadrant, sine, cosine, and tangent. But in our example, we have cosine of theta equals a negative value, so we don't want cosine to be positive. In the second quadrant, sine is the only one that's positive. Third quadrant, tangent's the only one that's positive. In fourth quadrant, cosine is positive. So we don't want cosine to equal a positive value, so the fourth quadrant is out also. Okay, so now that leaves us, we need to find a solution in the second quadrant, and we need to find a solution in the third quadrant. All right, so to do so, what we'll do is use that reference angle. The one in the second quadrant, what you do is you start with pi, and then you move backwards however big that reference angle is. So our reference angle is going to fit right in here. It's pi over 3, just a reminder. So to make that calculation of the angle that wraps around from 0 into the second quadrant, I'll call it theta. What we'll do is we'll start with pi, and then we'll subtract away our reference angle. All right, so subtract pi over 3. Oops, I don't want that to be a theta bar. I just want that to be a theta. Just to be clear here, it's not the reference angle. It's the actual solution that we're finding here. All right, to clean this up a little bit, I'm going to rewrite it as 3 pi over 3 instead of pi. So we get that common denominator. And then combine these together, we get 2 pi over 3. And for the third quadrant, it's pretty similar, except for we're going to start with pi, and reference angles are always drawn into the x-axis. So we're going to extend it further by theta bar. So theta bar past pi. And remember, the idea is you're trying to calculate what is this angle that wraps all the way around from 0, as radian measure, all the way into the third quadrant. So that is going to be given by, you start with pi, and then you add pi over 3, your reference angle to it. So again, just rewriting this, 3 pi over 3 plus pi over 3 to get that common denominator. It's going to be 4 pi over 3. All right, but to illustrate this as all the possible solutions, we can wrap around over and over again, right? This is a periodic function. So to the end, we're going to add 2 pi multiplied by k, where k is some integer. So solutions here, and over on the left-hand side, either both of those or listed out individually, or combine them together into the pi over 2 plus pi multiplied by k. So I hope this helps out. I know factoring throws people off a little bit, but remember, factoring a common factor really isn't that bad. Just take your time as you go through them, and you can get through them. Good luck.